This is problem 3 on practice exam 9 of chapter 1 in the book Problem Solving with Differential and Integral Calculus. We have strontium-90, one of the major radioactive products released when a bomb is detonated. And nuclear power plant failures introduce a large amount of strontium-90 into the environment. It's right under calcium in the periodic table, which means the body treats it like calcium, sending it to the bone and teeth. The half-life is 29 years, so humans get it inside of them, and a large fraction of it decays in their lifetime. So here's a graph of the number of strontium-90 nuclei remaining when you start with 7 gazillion of them. I'm going to call it gazillion. It's a 7 with 15 zeros. There it is right there, 15 zeros. So that's 7,000 trillion, which is like a millionth of a gram. It's not much strontium at all as far as weight. It's a lot of atoms because the atom is so small, so light. So a person gets a millionth of a gram of strontium-90 when they're 20. How many of these atoms will decay on the day of his 60th birthday, which is 40 years later? Nice problem. There's no way you can read it off the graph. There's no way you can go 40 years. Let me go over one day and see how much it drops. Right? We need to get delta N, delta T when the person is 60 years old. How do we do that? We need the tangent line at 40 years. So locate the point. It's right here. Draw a good tangent line right there. And then it's dropping. That's 5.2, 5.4, up to 6, so that's 5.2 times 10 to the 15th. That's negative, of course, because the atoms are going away. And the time looks like, oh man, I don't know, 83 or something? 83, okay. 5.2 times 10 to the 15th divided by 83. So the decay rate of the strontium-90 at 40 years is this. So all we have to do for the run is substitute in 1 day. Delta T is 1 day. And of course we have to take care of the units here. So we'll multiply by 1 like this. 1 year is 365 days. A fraction is equal to 1 when the top and the bottom are the same. Don't send me emails about I didn't include the leap year. This is just ballpark. Okay, so the answer is quite shocking. It's 170 billion. This young man had a millionth of a gram of strontium-90 enter his body when he was 20. On his 60th birthday, 170 billion strontium-90 atoms will decay inside of his bones and teeth if he lived that long. That's assuming he lives that long. Sometimes the strontium can dissolve from the bones and is expelled from the body, so we're making an assumption here that that didn't happen.